Hi, and welcome to our next level 3 integration video. We turn our attention to integrating e to the power of x. Now, in mathematics, e is an important number just like the number pi. E is equivalent to this number here, and although it may look like a bit of a pattern, there are no patterns or repeats, and those numbers go on forever. It's an irrational number, and this number was named after the mathematician Leonhard Euler. Now, e is so unique that if we take the function y equal to e to the power of x, it differentiates to itself. However, also remember in differentiation, if we have y equal to e to the power of some function u, then it differentiates to e to the power of the function u times u dash. U dash is the derivative of u. Now that's a composite function idea. Now we're going to use that later on in these videos because we're working backwards. So if e differentiates to itself, then e integrates back to itself. Right, let's get into some examples. Example 1, let's integrate e to the power of x with respect to x. Well, the answer is e to the power of x plus c. Nice and easy to warm up. Okay, example 2, let's integrate e to the power of 4x with respect to x. Now the answer is e to the power of 4x divided by 4 plus c. Now why have we divided 4 in this idea? Because this is the function of u coming into play. We've got a function 4x, which is u, and we, instead of timesing by u, which is what we do when we derive something, we have to divide by u dash because we are anti-differentiating. All right, let's go to example 3. Let's integrate 3 times e to the power of 5x with respect to x. So the first thing to do is you might want to think of it like this. We have 3 times e to the power of 5x. Leave the 3 alone when we integrate and take the function e to the power of 5x and write it as e to the power of 5x divide 5. Now this is another one of those u dash functions come into it. We have to divide by 5 because that is the derivative of 5x. Instead of timesing by u dash, like we do in differentiation, we have to divide by u dash when we anti-differentiate or integrate. Now this will tidy up to get 3e to the 5x all divided by 5 plus c, and you could have seen from the start I could have just divided the whole thing by 5 and put my plus c. All right, example 4. We're going to integrate 4 divided by e to the power of 2x with respect to x. Now to solve this problem, we're going to take the e to the power of 2x back up to the top of the fraction and make it e to the power of negative 2x. Now we're going to integrate and we're going to write down 4e to the negative 2x. We leave that alone. And then we must divide by negative 2. Now why have we divided by negative 2 again? Because it's the derivative of u, and u is equal to minus 2x. Right, if we tidy this up, we're going to get 4 divided by negative 2, which is negative 2. So we end up with negative 2 times e to the negative 2x plus our constant c. And finally, if we take that e to the minus 2x and put it back to the bottom of the fraction, you will see that we get our final answer, which is negative 2 divided by e to the power of 2x plus c. Right, one last example, and this we're not going to be able to solve this problem, but we're going to show you a small problem that you may come across. And we're going to look how to solve these later on when we get more complicated. So we're going to integrate e to the power of x squared plus 2x with respect to x. And you may think it's as easy as this. E to the power of x squared plus 2x all divided by 2x plus 2 plus our constant c. Now you're thinking, yeah, that's what I would have done because 2x plus 2 is the derivative of x squared plus 2x. But unfortunately, it's not that simple. That's because the function u is more complicated and it's not just a number. We can do this if u dash is just a number. So just have a quick look at what would have happened if I took e to the power of x squared plus 2x divided by 2x plus 2 and differentiated it. I would have got this function at the end, and this is not equivalent to the original. So be careful of this. We're going to show you ways to deal with more complicated functions like this later. Thanks for watching.